Hello and welcome to CS Honors. In this video, we'll be talking about Git and how you can use it for your version control needs. So just a heads up before we get started, these lesson videos are going out to both CS 124 honors students and CS 128 non-honors students. So as a result, there are going to be parts that will be different for each, and those will show up at the end of each video, and I'll tell you which ones you should be clicking on for each course. So just be aware of that. So let's get started. So what is Git? As I mentioned before, Git is a version control system, which is a fancy way of saying that it allows you to recover previous versions of your work as well as to work with other software developers, which is really nice because it allows you to collaborate with anywhere from one other person to 100 other people really, really easily. It's a very great scalable solution. And it's also the most commonly used version control system in the software engineering world. It's so commonly used that we have a bunch of different companies listed on the next slide to show how many people use it. So let's show off some of those companies that use Git. They include Google, Spotify, Microsoft, Adobe, Amazon, Twitter, Netflix, LinkedIn, and Airbnb. All of these companies that are all very well established and very popular in the software engineering community have all agreed that Git is the best way to keep all of their versions synced, all of their file versions synced. So if all of these companies can agree, and if, according to Stack Overflow, 94% of developers either use or know how to use Git, it's probably something that you should at least take a look into learning. So now that we've talked about why you would want to use it and how popular it is, let's talk about the how, right? Let's give a high-level overview of what you need to do to work with Git. So at the high level, Git will store your code in snapshots. So these snapshots will show your code at different states. So for example, you can say, hey, take a look at my code right now and make sure to remember it. And then 10 minutes later, you can take another snapshot, right? And you can keep taking these all the way until infinity, as many as you want, as few as you want, but the more the better because it makes it easier for you to go around and pick one that suits your needs. So these snapshots are called commits because when you take the snapshot, you are committing them into a log of all of the snapshots, right? So these commits all build up and they store data about what that snapshot looked like, as well as who made the snapshot and all of that kind of stuff. So then these commits are stored in a repository, which is a fancy way of saying a list of commits. And it stores other metadata, as I mentioned, like when the commit was made or who was making that commit. And so then these commits can be uploaded to external repositories on other servers that are hosted either by GitHub or by a company, whatever. And so what you're able to do is you're able to send other people your code by sending these commits. And then finally, at any point, you can then go to one of those servers and check out a commit to see what that commit looks like and what that snapshot had in the code. So you might be thinking, wow, that's a lot of vocab, right? There's, I think, one new vocab word per slide, and I agree. It's very complicated to see at the first, and you have to kind of get a feel for what Git is. So we're going to run through a quick demo of what Git looks like, just at a high level without showing any code or anything like that, and hopefully that'll help. So let's visualize Git. So we're going to make a shopping list, right? And on the shopping list, we're going to have a couple items, including apples and grapefruit, right? So maybe our roommates might want to all include ourselves on the shopping list and make changes as we go. So what we're going to do now is we're going to take that snapshot or that commit. And we're going to say, remember the shopping list with the apples and the grapefruit. And when we take that commit, then it will store all that inside the repository, right? It now remembers, hey, at this time, this commit was made by Matt. And so now you have all of that in there and you can now store it. So now what you can do is you can maybe modify the directory, right? You can now add like oranges and strawberries to your shopping list or something else, right? And now if you were to go back to that initial commit, you would still see apples and grapefruit on your shopping list. But now what we can do is we can take another snapshot, right? And now we have both a snapshot with grapefruit and a snapshot with oranges and strawberries in there, right? And so these snapshots or commits are able to be looked at in the future. And it shows, hey, I wanted to add this, and you can maybe take a look at why. And that's where a descriptive message like here where we say replace grapefruit with others. Now we know that we were removing grapefruit and we put something else in. So it helps us find this commit if we need to look at it in the future. So we're going to add one more thing, including bananas, and we're going to make one more commit. And so now what we have is the initial list, which is going to be apples and grapefruit, and that's in that initial commit. And then we have another commit that stores apples, oranges, and strawberries. And then finally, we have one that stores apples, oranges, bananas, and strawberries all together. Right? So now we have all three of these commits. Let's say we want to go back and take a look at the original list, right? Maybe there's a dispute on what was originally on the list or something else, right? All we have to do is check out that commit and you'll see that we had grapefruit on it, right? So now we're able to see, here's what that snapshot looked like. And so this is really useful if you're stuck on a bug or something and you're not sure when it started. You can actually go back in time, look at your code from a previous version and see if the bug still existed there. And if not, you can actually take a look at all of the files that were changed since that commit and look at, hey, what could be causing that problem that was changed since this version of the commit. And so let's go back to that bananas shopping list. And there's one other thing that we can do. Let's say we want to have it on an external server so all of our roommates can modify the shopping list, right? So what we can do is we can package up that repository, which is, as you remember, a list of commits, right? It stores all of these commits and what data they store, and we can send that off to GitHub, right? So we can package it up and push it off to GitHub. And so that is now sent to a server. It's accessible by anyone that we want. We can make it private or public, and it allows us to now have it elsewhere. So let's say if our computer died or something else, we can now still access it in the future by retrieving it from that server. And so now what we can also do is we can take a look at that list, and let's say our roommate says they updated the list. And so now what we can do is pull a new commit, download it, and look at the new updated list. And so in this case, it looks like our roommate removed apples from the list. So now we're able to essentially collaborate by sending these commits back and forth to this third-party server, right? And this helps us because we keep a log of everything that's going on, and we're able to make things go very quickly between our server and our own devices. So let's do a quick little bit of vocab review before we show how to do this in a real computer. So we have a directory, which, as I mentioned, is a folder on your computer system, right? So just think of a folder, that is a directory, right? They're interchangeable, they're synonyms. Then you have a commit, which is a snapshot of your code at some time where that commit was made, right? So when you say, hey, I want a snapshot, you're making a commit, right? So you'll say, I need to commit this to the repository. Speaking of the repository, a repository is a part of a directory that says, here's where all of the commits are stored. Now this is hidden to you as the user, but it allows you to store all of that data in a safe location. And so this is what gets uploaded and downloaded to and from GitHub whenever you're sending a push or a pull. And this way you can make more commits and then retrieve them and send them, and it allows you to essentially store them. Now, of course, there's also a local repository, which is specifically the repository that is on your computer, right? Because when we talk about repositories, it could be the one on GitHub, or it could be a one on someone else's computer, or it could be your own, right? So your local repository is the one that you are actively working on. And then finally, we have origin, which is a nickname given to a repository hosted on a server. So this is seen as sort of the source of truth, right? That's where the official, quote unquote, version of the code is kept, right? So in this case, you would push your commits from your local repository to origin, and then it would store them. And if someone else did the same, you could pull them from origin. So yeah, now that we've talked about the vocab and we've kind of cleared up what Git does, let's actually go into how you can actually do it using bash. So the first two commands that you'll want to use are git init and git clone. So what git init does is it'll create an empty repository in whichever directory you're currently working in. So if you're working in your downloads directory and you do git init, then it will actually start tracking your entire downloads folder. Obviously, you usually don't want to do that. So make sure that you're usually in a project directory that you've already started. So this is really great if after this lecture you're like, oh, I have a project that I want to get uploaded and keep safe. Then this is a perfect command for you because you can just run git init, make a commit, and you'll now have all of your code stored in that repository, and you can then upload it. Git clone, on the other hand, to run git init, you need to run or type git init into the command line. So we'll show that off in a minute. And yeah, as I mentioned, there will be no commits or files tracked initially. So when you first run git init, it'll be an empty repository and you still need to take that first snapshot. It doesn't happen automatically for you. So yeah, then we have git clone. Git clone is great for when you want to download an external repository from some server and set it up as a local repository in your current directory, right? So this would be something you do run in your downloads folder because you want to download it from somewhere else. Or you can run it on your desktop. Wherever you want to put it, you would cd into that directory and then you would clone. So to use that, all you have to do is type in git clone and then paste the URL to your Git repository on remote, right? So usually there's a button that you can click to copy that and then you can just paste it into your terminal. So now that we've talked about how we can create or download a repository, let's show that off in the next clip. All right, so now that we've got our environment set up, let's go into how we can clone a repository. So if you're in CS128, please make sure that this is on your VM as opposed to on your personal machine's overall computer, because remember, your VM has a bunch of stuff that makes sure that you can get help in office hours and that kind of stuff. If you're in 124 honors, this will be done just via VS Code or whatever else you want to use. If you want to just use the terminal from your computer, that's totally fine. So to get started on cloning a repository, we have to actually go to the website wherever this is being hosted, and in this case, copy the URL from GitHub, right? There's a big green code button. It's that easy. And once we have that, all we have to do is open up our terminal. And in this case, I'm doing it on my laptop. But remember, once again, if you're in 128, this should be in your VM. So in this case, I'm going to be putting it in my downloads folder. In reality, you can put it anywhere. Once again, this varies for 128. So to clone your repo, all you have to do is do git clone and then paste that URL. And once you do that, it may ask for a passcode or something else. Just make sure that you're entering that information. It really depends on which person and which VM and all that kind of stuff. It might ask for your username and password. It might ask for something like an SSH key like I have. It really depends on your own setup and configuration. But all you have to do is enter in whatever passcode you have. And once you're done with that, which I will cut to in a second, it'll clone like so. And so now if we do cd shopping list, you'll see that we have all of our files. And if we do git status, we can see that we're on main. So now let's open this up in VS Code and take a look at the repository. All right, so now that we're in our repository in VS Code, you can see that we have our simple shopping list right here as a README file, and we can see that it's just like what we have in here. And you might notice the formatting is a little different. That's just because I'm not previewing it. So there we go. So now that we've got that, let's go take a look at how we can now make our own changes to these files. So the next command is git add. Git add is what tells Git which files we want to be committing or taking that snapshot of the next time we run the commit command, right? So it also doesn't automatically commit the files. You need to run git add before you run git commit. So to use git add, you can either do git add and then a specific file or a directory that you want to add things in, right? So you can either add a specific file like myshoppinglist.txt, or you can add an entire directory, right? And it would add all of the files or subdirectories within there. You can also do git add -a, which is going to add any and all files that are in the repository. So be very careful with that one, because it can obviously be a pretty big change depending on what you're using. And so be careful, especially if you have, say, some sort of artifact from when you compile something, because usually these can get caught up with git add -a. And then we have git add -u, which is slightly safer because it will only add files that have been changed or deleted, right? So it allows you to only look at the files that were removed or you made a change to, which is usually safer, but you can always add the other files that you might have added since your last commit. And so one quick note is that git add will not add files in your .gitignore, which is a special file, by default, right? So if you want to learn more about this, you can Google .gitignore, and what that will tell you is basically here's a way to tell Git which files to ignore, right? So this is really great if you do have something like those build artifacts, because then you can do git add -a and it will ignore them but still add any new files elsewhere. All right, so now that we're back, let's talk about adding. So let's say I add oranges to the shopping list, and maybe I'll also add strawberries while I'm at it. Berries. All right, so now that I've made a couple changes, let's go and add the README file so that it gets added or committed in our next commit. So what we do is we do git add, and in this case, we're going to use just the standard adding this file as itself, right? And now, as you can see, if we were to do git status, we can now see that it's to be committed the next time that we run this, right? And now all we have to do is now commit this. So let's take a look at how to do that. All right, so the next command, the most important command, is git commit. This command is what is taking that snapshot of your code at a given point in time. So, as I mentioned, it commits those files that you've added to the repository, to your local repository. And it will also add the metadata like your email, your name, and when you made the commit, right? All of that gets added to this commit and put into the repository, your local repository. And so to use it, all you have to do is type in git commit if you want. And what it'll actually do is it'll open up your native text editor, usually Vim or Emacs, and will allow you to write your commit message in there. Now, this can be cumbersome if you want a one-line commit message, so what a lot of people will do is they'll use the -m flag and put a different commit message in quotations. And so what this will do is it will tell Git, hey, don't open up that editor, just take what I put in quotations and that's the commit message, right? So if you want to just make a quick commit, this is all you have to do. This is usually what I would use is git commit -m, and then I put whatever message I need in quotations. And then finally, you can also use git commit -am to commit all changed files, right? You don't have to do git add if you use the -a flag, and confusingly, it will actually do git add -u and then run git commit -m with your commit message just like before. So it's a little confusing, but essentially all of the changes will get committed and then it will use the message just like before. So let's take a look at that now. All right, so now that we've added the file, let's go back and commit it now. So as I showed you in the slides, all you do is type in git commit. In this case, we're going to use the -m flag to add our message here. And we can say added apples, or added oranges and strawberries, if I can spell. There we go. And once we hit enter, it will now add that commit, and we can now push it back up to GitHub. So let's take a look at what that needs to do. All right, so now that we've made our commit, let's make sure that we're able to push it to GitHub, right? And so what we can do is we can run the git push command to upload any new commits to Origin, which is GitHub. And so all we have to do for that is run git push, and if this is an existing repository and everything, it'll just automatically send it to GitHub. If you ran git init and you might have a new repository, you might need to do something like this. It'll tell you when you try and run git push if it doesn't work, and it'll give you the command that you can just copy paste. So this is usually what it'll look like, but essentially this is pushing your commit to your origin for the first time. And we'll go more into exactly what this is doing in the next video. All right, so to push, just like I showed you in these slides, all you do is type git push, and sometimes it'll just work when you enter your password, or sometimes it'll require you to do -- set upstream origin, and all that's doing is telling Git, hey, this is a new repository. So if you see that, just follow what Git prompts you to do. Otherwise, you can just enter your username and password just like when you were cloning, and everything will be good to go. All right, so now that we're done entering the password and we've pushed, you'll see that everything went through. And if we go over to the website and refresh, you'll see we now have our new additions added to our shopping list on our origin repository. So now that we've pushed everything, we're good to go. But now let's say that someone makes a change on GitHub and removes strawberries from the list, right? Remove strawberries. And now that that change has been done, let's figure out how to pull it back down to our local repository. So let's take a look at pulling. All right, so our final command is git pull. So what git pull does is the opposite of push, right? It will download any commits that are in origin, but you haven't actually put in your local repository yet. So this will allow you to get any new changes that have happened and put them on your own computer. So to use it, it's very simple. Just run git pull. It's that easy, right? As long as you don't have any issues, which once again we'll talk about in the next video, git pull will just automatically take any changes that are in origin and put them on your computer. So let's take a look at that in action. All right, so to pull, just like I said, you just do git pull, enter your password like so, and everything will just very quickly change. And as you can see, the change has been reflected immediately. So there you go, that's git pulling, and now you have your simple Git workflow all ready to go. So let's do a brief overview of what you learned today before we talk about what videos to watch next. So we showed how to use git init and git clone to either create or copy a repository. We showed how to use git add to add those new files, and git commit to take that snapshot of those files, as well as git push and git pull to send them and receive them from origin, which is usually a server like GitHub. So this is your basic workflow, which should get the job done for most scenarios, and this way you're able to do a very basic workflow. So yeah, in the next videos, you're going to learn about two different things. So CS124 honors, you're going to take a quick detour and learn about how to do this basic workflow, but using GitHub Desktop, which should be a little bit easier for you to learn because it's a GUI-based application that does the same thing. In CS128, you'll be moving straight on to the next video where we're going to talk about branching, merge conflicts, and other ways that you will work with people in the real world.